Picture a modern solar panel. It's sleek, it's silent, it's basically the poster child for clean, green energy, right? But what if I told you that the journey that pristine panel took to get to your roof is literally fraught with geopolitical tension, extreme resource scarcity, and some pretty intense environmental hazards? Today, in this explainer, we're unpacking what is arguably the ultimate paradox of the renewable energy transition. We're going to look past the shiny surface and examine exactly how the solar industry tracks, measures, and manages the immense risks hidden deep within its supply chains, specifically using the official sustainability standards from the SASB framework.
Okay, let's jump right into the agenda. First up, the hidden side of solar. Second, managing critical materials. Third, risk mitigation strategies. Fourth, securing the polysilicon chain. And finally, audits and corrective actions. Section 1, the hidden side of solar. Now, you might be wondering, why does tracking supply chain resilience matter so much for solar developers? Well, because without a secure, ethical supply of raw materials, the entire global transition to renewable energy basically grinds to a sudden halt. It's not just about doing the right thing anymore, it's about pure financial viability and operational survival. To actually measure this, the industry relies on highly specific accounting standards. The SASB, which you know is now part of the IFRS Foundation, lays out the roadmap here. We're focusing on two precise metrics today, RRST 440A.1 and RRST 440A.2. These aren't just random, arbitrary numbers. They are the exact disclosure frameworks that solar companies are required to use to report exactly how they're handling critical material shortages and environmental hazards in their supply chains. And if you look at where these metrics actually sit within the official framework, right under the materials sourcing topic, you'll see they are qualitative metrics. They require discussion and analysis from the companies. Regulators and investors don't just want a simple box checked. They want a comprehensive, detailed explanation of how these supply chain risks are being actively managed. Moving on to Section 2, Managing Critical Materials. Metric RR-ST 440A.1 is all about the physical availability of the materials needed to build these panels, the wild shifts in their pricing, and the intense regulatory and reputational risks involved in sourcing them. But first, we have to define what we actually mean by a critical material. According to the SASB standard, a material has to meet two distinct criteria. It must be absolutely essential to the manufacturing process, and it must be subject to the risk of supply restriction. So it's this dual threat, right? You literally cannot build your product without it, but getting your hands on it is incredibly difficult or unstable. Just look at the sheer volume and geopolitical complexity of what solar developers actually need. We're not just talking about basic aluminum and glass here. We have base metals like cobalt and antimony. We have platinum group metals like palladium and rhodium. And then, of course, the notoriously difficult rare earth elements like neodymium and dysprosium. Many of these materials are heavily concentrated in regions that, well, have limited regulatory structures or are subject to really intense geopolitical tensions. This exposes companies to massive, potentially crippling supply chain disruptions. Section 3, Risk mitigation strategies. Because knowing the risks is great, but it isn't nearly enough. The SASB standard requires solar companies to officially disclose their strategies for mitigating these critical materials shortages. They have to prove to investors that they actually have a plan. Companies generally employ a mix of short-term and long-term strategies to handle this. Take stockpiling, for instance. This provides a physical short-term buffer against supply shocks, but obviously it's incredibly expensive to buy and just sit on massive amounts of raw metals. Contrast that with investing in recycling technology. Now that is a long-term systemic strategy to reclaim metals from end-of-life solar panels, essentially trying to create a circular supply chain that reduces reliance on those volatile global mining operations altogether. But the standard doesn't stop there. Companies also have to disclose if they're diversifying their suppliers, just so they aren't overly reliant on one single region or, one specific mine. They also need to report on their research into alternative or substitute materials. Now, a really important caveat here. The SASB standard explicitly states that these disclosures should be specific enough to show a concrete plan, but they don't actually require a company to compromise its confidential trade secrets. So they can describe the strategy without giving away the proprietary formulas, which is a big deal for these tech developers. Okay, so we've covered the scarcity of the raw metals, but that leads us to a massive, often overlooked question. Once you actually have the materials, what about the environmental impact of the manufacturing process itself? Because building solar panels is a heavy industrial process, and it inherently carries heavy industrial risks.
Which brings us to Section 4, securing the polysilicon chain. This is where metric RST440A.2 comes in, shifting the focus away from metal scarcity and directly onto the environmental risks that are heavily concentrated within the polysilicon supply chain. Polysilicon is the foundational material for most solar cells, and making it is no simple task. The SASB standard explicitly calls out the high risk factors involved here. Solar developers have to describe how they manage the risk of their polysilicon suppliers failing to comply with environmental regulations. A prime example highlighted in the text is the handling and disposal of highly toxic manufacturing wastes, such as tetrachloride. Think about it. If a supplier improperly dumps this waste, the reputational and regulatory blowback on the solar developer whose brand name is stamped on the final panel can be absolutely catastrophic. To prevent these kinds of disasters, companies must outline their proactive management strategies. And this isn't just about sending a strongly worded email to a supplier. It requires deep due diligence practices, active and continuous engagement with the supply chain, enforcing strict codes of conduct, and even partnering with non-governmental organizations to ensure that these overseas polysilicon plants are operating legally, safely, and ethically. Section 5, audits and corrective actions. Because, let's be real, writing a code of conduct is one thing. Actually enforcing it across a highly fragmented global supply chain is a whole different ballgame. The SASB framework literally forces companies to have a concrete operational backup plan. Step 1 is the ongoing auditing of the supply chain. When Step 2 occurs, meaning you identify a supplier who is in environmental noncompliance, say they're mishandling that tetrachloride we just talked about, the company must immediately move to Step 3, implementing corrective actions. And if the supplier cannot or will not fix the issue, Step 4 is the ultimate consequence, transitioning to alternative suppliers. You absolutely have to have a plan B. I want to highlight this direct quote from the SASB text because it perfectly summarizes the accountability built into these standards. The entity shall describe its process for implementing corrective actions in the event of noncompliance, including the use of alternative suppliers. It just proves that agility and ethical enforcement aren't just nice-to-haves. They are hardwired into the accounting requirements. If you want to be a top-tier solar developer, you have to be willing to walk away from a toxic supplier, period. Which leaves us with this final, vital question to close out the explainer. As the world races to decarbonize, the demand for solar panels is just exploding exponentially. We know frameworks like SASB exist to ensure these panels are built ethically and sustainably, but can supply chain transparency and rigorous auditing truly scale fast enough to keep pace with this booming global demand? It's arguably the ultimate tightrope walk of the green transition. Thanks for tuning into this explainer, and I hope this deep dive into the hidden supply chains of the solar industry has given you a totally new perspective on the panels powering our future.